Hello. 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 Hi. So like because I continues my learning path about Java, so I have figured out that to learn about Java. First I have to learn about Java course. So the the previous live stream I have like uh, learn learn about this through the tutorials and the book, my notes here, and kind of like read through like a half, just a half of the book, and it's a chapter 5 right now. So there are a lot of things that I have gone through, and like so to remind about what is the main idea about on the 4 chapter before, um I'm gonna have a remind about this. um in previous in the last stream, I think we have gone to the Java building blocks, I think so. So about um, I think to summarize, I have to go to the summarize topic. um in the second chapter about Java building blocks, we have like what is this? We have constructors. We have in Java we like code in OP, so we always think about objects in our code. So to create objects, we have a class, which is a like a plural of the objects, and and the class have, when we design a class, we need to have a constructor which create a Java object. And when you look at the class, you like to identify the constructor, you have to look at the name of the functions. It's the class name, and it have no return time, omitting the return time. Exactly. And inside the class we also have like fields and methods and block of code. Block of code here is a code that inside uh, a praise or parent. I remember let me check again. First we have a constructor inside class. Here's the constructor of the class. uh, here's either the attribute of the class. We initialize it in the constructor. It's two component, constructor and field. Fields initialize in constructors, maybe if you need. And the instant initialize block, the, this is the thing that inside the brace, the code between the brace. It can be inside a method, a main method of the class bird, or it's outside of this, just inside the class bird, using the two brace here. Is it curly brace? I don't remember exactly. So after have like three block in the Java class, now we have to like we have to define the order of initialization with about the fields and initializer blocks. So which come first is happen first, like here at the book says fields and in instant initializer block run in order which they appear in the file. So which appear first, it will happen first. It will like be combined and run first, and the constructor run like after on fields and initialize blocks. When you initialize a object here, when we initialize a jig, we create a new jig object. Because the field declaration here is like in the first line of the class is run first, and it sets block fee to a name, and the initialize block here run second, it brings set field, and after on the constructor run, it set the tiny to the name instead of the block fee at the beginning, so the name now is tiny, and bring out these setting constructors. And after, so back to the main function, the construct now in the main function. So after create the object, now we run the bring the jig name is a tiny. So only two things you have to remember: fields and instant initial block. Run which run first, which declare first, it will run first, and about the constructor, it will run final. And some other like methods, it will run whenever you call it. So it's on about the object, creating objects. Now about the data type. Primitive data type is like very familiar with who have study about programming language. It's really easy. Anything that we have to notice. Java we have a byte data type which is like 1 byte, a bit equal 1 byte, a new data type. And we have to like add the keyword L in the long, F in the float. That's this, and in not, well, we don't need it, just for the floating point. Double don't need this keyword. And we have characters. Notice here is string is not the primitive data type. Please remember that, because string in Java is a class. Here we have a like notice here. And about this, after we have primitive, we have reference. Reference is the data type that store the reference to the object. A reference refers to an object. So in basic, object or class is just like a set of primitive data type. They group it into a single thing called that object. Yes, we had day, month, year. This is just the primitive data type, as you know. Probably in and in. So they group it, and they will store it in a object, and it's a object and a reference type store in C++. I remember they store the address of the objects to the variable here to point to. Why? Because to run a, how can I say that? Because they have two types of memory in a when a program run. We have a stack to store a main program, like here is no program here, something like this. Is you have two lines of code, and today the first line of code create a new day's object, and the today variables is stored in the stack, the cone stack of the program. And when we create a reference, a new data type, no, a new data object, it will store in the heap. In here we store a heap in heap memory. So they just two different data types. In both of them is stored in RAM memory. Why they need to like separate it? I think it's the because the way that you access to primary data type is different than the way that you access to the object. Like primary data type, we just store it in a single whiteboard, I think. Fuck. So lag. So I say in we have like no. In RAM have like stack. We have heap is much more and larger than stack. In stack we like they aim to store the program code. No, like the process of the program when we run the for example here the code probably is in a function, main function. So the main function, so the first line of code we have the main function here. So the first line of code, so they read the main function line by line. So example the first line today, so we in like we create a variable today, and in stack we just store primary data, I think. Because the limit of the reality data is depend on the the structures, the architecture of the memory, and the OS. I think is the maximum is 64 bit. So you think the RAM is work like this, the RAM memory? So in single line, it's the 64 bit in the column here. No, I think a row is better. A RAM. It's 64 bit. So if we store the primitive data is in maximum 64 bits, and we just like cut a part of the RAM to act as the stack to make it better to read and write, because you can read a single data here in just a single read, because for example it's the reference today is stored in this line in this rows, and it's take exactly 64 bits. You can read it because the CPU is work properly. It's like to read the time, the like instead of read bit one bit one bit one bit until 64 bits, it read 64 bits at the same time, for example, I think. So it's much faster. So when we store their relative data type in RAM, they are not exactly 64 bits, they probably 33, they on divide by 2. So the CPUs and the program is like much faster to read in these number of data type. The size, when the size is even like this, they much easier to read, and we just store them in a RAM. So the stack is just I think a part of the RAM. When we store data type, we store the program when we init we store our code function, and when we have and back to our code. When we use the keyword new to create a new object, we have a reference today to store the address, and in the heap, because although they both of them is stored in RAM, but the structure of the stack is just exactly the same as the RAM, so much it's easier to read and write, I think so. And or probably heap is the same, I don't exactly, but the in heap we store we need to create a new object, because it's now not in a single line. Now we have days, we have lot of field in date, a day object. So we had date, month, I think, year. So we have a lot of relative data type in a single row. So when it's stored in the RAM, it must be like when here a variable is not a single line to read. Yeah, it's now a group of line. So now the way that the program read from the heap is probably different. The way it's read from the stack, as yes, as my analysis, I think so. So because they cannot read just in a single read, and they get the full data of the object. Now they have to access full of them. Oh, no, when we have to access X field, we have to like get to the first line and search in the search or the line in this group to find the field that we need, like the month field, the year field. So so in the program we just need to store the today preference, and it's point to here because it's store the address. I think in the I think for the address key it's probably like 0x01, and the object here is 06, for example, and the today store the address. Because like you cannot store the whole object in the RAM is not efficient, I think. Why we not store the whole object in this? Because we cannot read it at the same time. Why not? think I have to search it. Can we store in stack? Oh, but in Java, on object is stored in heap. This question. Heap the same. Class instant in array. Class in array. Instant is stored in heap. Method, thread, and variables. Local. Yeah, the stack only contain room T data type. Yes, as I say, and a reference variable. Yes. Oh, because we have heap, so store in heap. No, because we have thread, and if we store in stack, or the thread cannot access it. Or in stack we must have a merge non-fixed size data with unknown size comply outside function. Or it might be a good example. So back to this. So about the object, oh, I think the size of the object. Oh, because we have decided class, so the size of the objects must be predefined also. So it's not the appropriate here, but about the array, I think for about the array, it should be stored in heap because like we can change the size of the array. If 2 to 3, and if we store two variable of the array in the stack, and after that some function, some variable call, first element, two element, and something new here, and we have to adjust the size of the array. We cannot because there are some thing that like in the next position we cannot delete this one. So we have like a open area. So we have a heap like an open area to store expandable data, we can increase their size. So after about the reference, now we know that we store um, reference in stack and we store the objects or arrays in heap. By initial variable, we have three types of variables. We have local variables, which is a variable inside a function. Uh, instant variables is the variables of the object, normal variable of the object of the class. Yeah, like name, sign of the. No, not this. Where the class? Where the class? No, it's the above bar. Oh, đây we have it for the class mount the length in the instant variable and because it's instant, well, it's only accessed by the instant, can be accessed by the instant only. When we create an instant, we can access to this. About class is the instant variable that have the static keyword, because we can access it just using the class name, and it's the declare. When we declare the class, we don't need to like create an instance to access this field. We don't need it, so we call this class. So the name is m for the position or the time that we can access to this variable. In local, we can access inside a function whenever it's created, so it's in a local scope. And about instant, we can access it when we create instant class, when we can access it inside when we declare the class. So it's also like related to the scope, the local inside function. So it's like born in the function and die in the function. The instant is born when the function is declared when the function create, and like destroy when the function is, when the object, the instant is destroyed, and the class is also is is create when the class is declared, and when and it's destroyed when the class is destroyed, but the class is like never will destroy until the program is end, so it's alive until the end of the program. So we have garbage collector here because we have like objects as I said before, they array because we don't directly have it in the program, we just store the reference to it, and somehow in the program we change the reference of the variable here. It's no, we have a new date. And we no no we started this to the today variables at this time. Oh, it's, it's must I think no it's must change here. It no I never start the 06. It's will start the 010 for example. It's started 10 for example, and here no one is access to this reference this object, so we have something to like destroy it, to erase it, to have space for other variables. So we have a garbage collector. So about garbage collector, how it works, because it's pretty easy. Like you read the program, you notice that whenever the an object it like no variable spawn to object, so it's not accessible again. So at this time it's like able to be collect, so we can at this time we connect objects like remember eligible. Yeah, it's become eligible to be collected, because nothing pointed, so you have nothing pointed, so you cannot assign or like on the connection is cut off. You have no way to access this. You don't have the address to go to this, so it must be collected. So we consider it as garbage. So this is the first condition. No references or we have a today is still point to the day 2, but the when we have like the program stack, we have gone to on the stack of the program. It's here is the main function, and we have gone to the main function, although we have still have a reference to it, but have, if we go to the program, so we don't the stack is removed also, so we need to delete this one also. So this is the second condition. The function is out of scope. No, the reference today is out of scope of the program, because it's no never have in the program, because we have run to the main function. So next chapter is about operator. I think then nothing to be noticed. Watch the summary. Nothing. About making decision. It's about the control statement, if else, the loop. Anything that we have to notice? I think it is same as other language. Only one thing else is about the like a something like the notation, a label to here the optional label thing that we have to notice, because when we have nested loop, and we have like up after the first loop we have the second loop, and inside it, if it match some condition, we want now break, not just break the second loop but also the first loop. But in normal case we have to like have some additional variable here, like for one, the first for, the second for, and if the condition is match, we break. Here we want to break the whole for on the two for. How can we do this? In normal case we have to like create a new function like whole break, full break something. We have to create a new variable full break bằng equal to, and it in the first for we have to check if full break, so we break. So the normal ways we have to like coding like that if we want to break on the for loop. With just two for loop is like acceptable, but if we have 3 or 4, although it is like this kind of native for loop, is if we have too much it's not good in coding, but somehow they in Java we have a way to like, instead of checking condition in each for loop, to have a break to loop, break of the for loop. We have a how can this, the optional label. We have label here is loop 1, L2, loop 2, loop 3, loop 4. So instead of using an additional variable, when we break, we can choose the loop that we want to break. We can like directly break the loop 1 just using L1 here, and it's like automatically break out the loop here. So go to the next line code out group. So it's much easier to code, much efficient, and not using in loop. In for loop it can be used in while loop, I think. In if also is in while for loop. Just in loop. It must be uppercase and the comma. Or in if, in the if we can use it like to make the program like easier to read properly. So it's about the 4 chapter. So that's this. I have read 4 chapter. So about the 5th chapter here is like really important one. And still not read yet, and I think in the next slide I'm gonna go to this. build after learning about Java core, we like gonna learn about building web, because in real world we working with web in real product, web or app, not just a single program like in big code or HackerRank. So about learning Java web, and like I heard and researched it, in the early day they use Servlets and JSP to build a web Java website with like both backend and front end in Java. This one is for backend, I think, and this one is for front end. So gonna, and because the Spring run is based on Servlet, so Spring is also used for backend, and in current day they use Spring a lot, and Spring is based on Servlet. So I think I have to understand about it. Okay. And I want to understand about it. So for learning about Spring, we learn about Servlet. So keep the Java core here. We're gonna back to it like tomorrow, and after I read those the chapter, I gonna summarize.
So we got the request and response finished, right? But let's say if you're asking for a page which is different, which is from the which will be built at runtime. So a client sends the request to the server. Now server says, hold on, I don't have any page with this link. So you have to make that page, right? And you have to.
So about so I have to learn about Servlet. Oh, I think I have to change the name first. So about Servlet, I'm gonna watch this video
to build that page. So that request goes to a helper application. Can you see that we got a helper application on the server? Now this helper application is also called as web container. Okay, so in this web container you'll be having servlets. Now what is servlet? So servlet is basically a Java file which can take the request from the client on the internet, and it can process that request. It can provide you a response in the format of HTML page, right? So this servlet will convert your request, and it will take your request, it will fetch the values, it will process the information, and it will send the HTML page, right? So let me just go back once again. So from client side, request goes to server. On the server side, since it is a dynamic request, it will go to your web container, which is, so whatever web container we have. So we have Tomcat, we can also use Glassfish, we can use JBoss, we can use WebSphere. In fact, all these other servers, those are called as app servers, but they also have a feature of web server. So basically, we always use Tomcat. In fact, in my subsequent videos, you will find all the things inside using.
So we have client, like a browser, which receive HTML file from our server, which is based on a web container, which is a
Tomcat, right? So
Tomcat. A web container.
Tomcat is a web container. So on your server, if you want to achieve the dynamic web pages, you need to install Tomcat. Okay, so you can see that is Tomcat there. So that web container is a Tomcat. So when request goes to your Tomcat, Tomcat says, hold on, I got a request now, but that request is for abc.htm, and we don't have any page as abc.htm, right? So we have to build that page. So that request goes to a servlet. Hold on. servlet will be having a Java name, right? Example, when you create Java classes, let's say I want to add two numbers. Again, a basic example, if I want to add two numbers, I will be having a...
So this whole thing is a web container, or just this one? So this one, so I think this one first. So when the request come to raw his image like much it's use less memory than the we have a client. No. Client or browser. And we'll send a request. To our server. So a server is like a group of lots of component. In here we have a Tomcat. We see a web container. So the request will come to this Tomcat server first. And inside it we have a servlet.
So I will be having the servlet name as add servlet. That means when a request for abc.htm, the page which should be getting called is your servlet. How can we do that? So what we have is inside your container, you have a special file which is called as deployment descriptor. And this is how it looks. So you have a file which is deployment descriptor in which you mention for which request which servlet should be called. Okay. So let's say in your Tomcat server you have maybe 50 to 60 servlets. So every servlet will be mentioned. Every request will be mapped with one servlet. It may happen that you have multiple requests trying to access the same servlet, right? Everything need to be configured in a file which is called as deployment descriptor, and the file name is web.xml. So this file here is your web.xml file. So let me repeat, when client sends a request, it goes to the server. Now server thinks, okay, this is the running page. Let's send the request to the web container. Now web container will check, okay, this request will be mapped by thinks, okay, this is the running page. Let's send the request to the web container. And the file name is web.xml. So this file here is your web.xml file. So let me repeat, when client sends a request, it goes to the server. Now
so when client send a request, it goes to the server.
Server thinks, okay, this is the running page. Let's send the request to the web container. Now web container, when client sends a request, it goes to the server. Now server thinks, okay, this is the running page. Let's send the request.
Cannot hear what he say at this time.
Server. Now server thinks, okay, this is the running page. Let's send the request to the web.
This have to be done in page, or it needs a page.
Container. Now when client sends a request, it goes to the server. Now server thinks, okay, this is the running page. Let's send the request to the web container. Now web container will check, okay, this request will be mapped by this servlet. That can be done with the help of web.xml file. So you can see in the
can hear clearly, but somehow a request that need a page. A response page. So the Tomcat is like it's the engine exactly when I hear. Oh. So both of them are a server. It's like it's act as a middle layer, servlet handle the business logic. As a coordinator or a proxy, I think. No, reverse proxy, reverse proxy, or a CDN, I think, probably a fact CDN, somehow like this. The thing that coordinate the request from the client to a modules that actually serve that request.
In the web.xml file, we have two tags. We have servlet tag and we have servlet mapping tag. So this
and we design the coordinate job a file. We design the coordinate in the web XML site deployment description.
So in the servlet tag, you have to mention the class name, and in your servlet mapping tag, you have to.
So because this has a request, so it know the page, so map the page with the request URL page to the class.
Have to mention the URL pattern. So for this URL, we need to call that particular servlet. But hold on, how do we get a tag? And we have servlet mapping tag. So in the servlet tag, you have to mention the class name, and in your servlet mapping tag, you have to mention the URL pattern. So for this URL, we need to call that particular servlet. But hold on, how do we get
servlet class?
the servlet now? And that's very simple. You can say we have a file here. So this is your file structure. So when you want to create a servlet, it's a normal class, okay, which extends HTTP servlet. Since we want this servlet features, right? We cannot create normal Pojo, which is a normal class. We have to create a special class which extends HTTP servlet, because this is
so servlet class is just a class extend servlet, because we want it to be coordinated and managed by servlet. I guess so. What he said next is just exact what I think.
The HTTP servlet will provide you all the features which you need.
Yes.
Okay. Now when I say all,
so want to be coordinated managed by the servlet and provide
all the features, it means it should be able to take request from the server, it should be processing the request, and it should be sending the response. How it will be done, that we'll see in the next video, but it takes the request, it processes the information, and it will send the response. Now that, right, we cannot create normal Pojo, which is a normal class. We have to create a special class which extends HTTP servlet, because this HTTP servlet will provide you all the features which you need. Okay. Now when I say all the features, it means it should be able to take request from the server, it should be processing the request, and it should be sending the response. How it will be done, that we'll see in the next video, but it takes the request, it processes the information, and it will send the response. Now that response will be in HTML format. Again, you can send the response in JSON format or normal string. You can send the response in XML format. You can also send the response in the HTML format. Now that HTML page, which is a dynamic page, goes from your server to your client machine in the format of response object, right? So now we have one more thing, right? We have web.xml file here. Do we have a replacement for that? Because the problem is we are Java programmers, right? And we don't like XML. That's not the case. But let's say we try to avoid XML. Now, how do we avoid XML? So in this Servlet 3.0, we got a new feature which is called as annotations. So we can use annotations on your servlet. So you don't have to use XML files or web.xml file. You can do your mapping using annotation. Again, how that is done, that we'll see in the subsequent tutorials. But this is how your servlet basically works with the.
Oh, so at this time, it's 7 years ago, we have an annotation. Instead of config in it's now fine. So it sounds like Spring.
Tomcat servers. Okay, so a quick recap: we have a client machine. Request goes to server. From the server, request goes to your web container. Web container uses a file called as web.xml to detect which servlet to call, and it calls the servlet. That servlet will process the information and it will send the response to the client machine. That's how it works. In the next video, we'll talk about how exactly your web.
So let's say client come to our server, miss the Tomcat, which is a web container, do map servlet. A lot of servlet here, and it will map the request to one of them. So sample, and this will like return the response to our like client. Map the mapping here using the web .xml. The way it is mapping, so that's enough to understand. In Tomcat, the servlet. Anything is
Web container.
did I split? Oh, it's 1 hour. So I think I will stop the live stream here, and to the next slide I will like continues. Just the overview. Just the introduction. Just the introduction.